Sir, shall we start, sir? Mushtaq, sir?
Okay, ma'am. Shall I play the video?
Yeah.
Yeah. Am I audible, Mushtaq? Mushtaq, sir?
Yes, ma'am.
Yeah. Good morning, everybody who has joined to this webinar. You all have seen senior to junior means it is always ragging, harassing, and some negativity in that relationship. But in AMCEC, it's guiding, imparting knowledge, and it's a tradition to students to give technical guidance either formally or informally. That is through seminars or workshops. Also, they can share the information with juniors and seniors. In that series, one name always comes to my mind, at least currently now, is Mr. Shayan. Mr. Shayan, the most enthusiastic, dynamic, multifaceted student, also an entrepreneur and tech enthusiastic, CEO and co-founder of Next Up Company. He is the recipient of Sharjah Sustainability Development Award. That's from the government of UAE. And he's also the guest speaker at ES University. And we are very happy to have a student like Mr. Shayan. And added to that, he is the president of our student forum by name Intellects of Computer Science and Engineering Student Forum of AMCC. The Student Forum of Intellects under Department of CSE was established in the main aim of knowledge sharing and knowledge enhancement by entirely student participation. All the responsibilities, the resource, the audience, organizing, coordinating, convening, all the things will be taken care by the students itself. It was to create an awareness among the students about the new developments in engineering and technology, the state of the art technologies of especially computer science and engineering domain. Under this forum, various activities like quiz, workshops, debates, seminars are conducted throughout the year, and students are encouraged to be the resource person. And as I told you, to impart the knowledge either to the peers or juniors, and sometimes seniors also. They will take some juniors will take the class or web seminars for seniors. That's very rarely seen in engineering colleges. A very few workshops to mention are workshop on competitive programming, virtual and augmented reality, ethical hacking, and MongoDB, along with some technical quizzes and debates. They meet every fortnight for brainstorming sessions, which acts as a stimulus and enhance their problem-solving skills both logically and technically. I would encourage all of you, all the students of AMCEC, whether it is computer science or other ways, to join the existing team and add strength to it and make use of the forum to the fullest extent. And regarding Shayan, I wish you, Shayan, a great success in all your endeavors. Be next up, be the next Facebook or Amazon or any such big companies, and you be the next Mark Zuckerberg of AMCEC. Okay. Uh, Over to you, Shayan now. Shayan, you can take
Thank you, ma'am, for that great introduction. Thank you so much. And to all the attendees, good morning. Good morning, everyone. So great to be here. So I hope everyone's doing fine amidst this pandemic. So first of all, before we begin, I would like to thank AMC Engineering College and the Department of Computer Science and Engineering. I would like to thank Mr. Srividya VR, Dr. Lata of the CS, head of the CS department, and I would like to thank Dr. A.G. Natraj, under whose leadership all of this was possible. So this is a great initiative taken up by AMCEC. It's really helpful for you. So let's get right into it. So I'm Minahi Shayan. I'm the CEO and co-founder of NextHub, and NextHub is basically a Bangalore-based edtech startup. But what we're here to talk about today is the world of machine learning. Now, let's get right into it. In fact, so what is machine learning? Well, what I'm going to do is I'm going to give you a few minutes. I hope your chat box is enabled. So why don't you go ahead and just tell me in a word or two, what is machine learning? What do you understand by the terms ML and AI? Yeah, so this is a very popular. These are very popular terms that come to mind. It's pretty hot in the market right now. Very popular terms: machine learning, artificial intelligence, deep learning, all of these things. You have them thrown around all over, right? So what is this exactly? What does it mean? Machine learning. Yeah, these are pretty it's from the word itself, what you can decipher is machines that learn, right? Artificial intelligence that is very bluntly putting it, artificial, right? But let's take a more deep dive into this. What exactly is the point of this workshop? So we're not, most machine learning workshops, they get into the nitty gritty of it, they get into the code, they get into the statistics and the algorithms. But what I want you to do is, the reason we're doing this is, I want you to stop for a moment and just take a look around you. Take a holistic approach to understanding, what are we doing? What is the technological progress that we are making so far? And where does humanity stand currently in the field of machine learning? Where are we? Where do we want to get? Where have we come from? So, what are the cool things that we've been able to achieve? What are the breakthroughs and the milestones that we have achieved and are yet to achieve? So, this is just something to give you an overview, a holistic overview of what's going on. All right. So, to answer this question in greater depth, I'm going to take you back in time to the dawn of humanity. Yes, that far back. And if you think about it, from the dawn of humanity, everything that humanity has been doing is, we have been creating tools. We have been developing and creating tools that can help us do our work better. Right from the Stone Age, we created tools that look like this. A few centuries later, our tools evolved into looking like something like this. This was the industrial age. And that continued to evolve. And currently, our tools look like this in the digital age. But there is one thing in common. Ever since the dawn of humanity, ever since the invention of the wheel to the tools that we have today, there is one thing in common. And that is that all of these tools are instructed by humans. The chisel only struck where you struck it, right? The computer only does what you ask it to do. But for the next era of tools of humanity, we want to create something that is drastically different. We want to create tools that can function independently. We want to create tools that are smarter than us, faster than us, stronger than us, better than us in every possible way. So it is a drastic turn that we are planning to take for the next era of tools. And how do we do that? Where are we currently? The truth is, these tools in some primitive form already exist today. May it be something as simple as the assistants on your phone, the voice assistants, or something as primitive as to some form of single player AI that plays against you in your mobile games. Yeah. But the thing is, it's not just in games and assistants. we use some form of AI every single day around us. In fact, every single social media uses some form of primitive artificial intelligence. Maybe something as simple as to curating your newsfeed to show you the content that you want to see, to something a little more complex, such as analyzing consumer behavior, identifying trending topics, brand passion and sentiment. So, much more complex analysis related to these things. All of these are done using some form of primitive AI. Even multiplayer games to this day run on AI. So, but the thing is, AI is doing much more than just playing games against you like this. Um, what you might say. So, I would propose, let's say, the game of Go, right? By looking at this, you might say this looks exactly like chess, right? But how is this anything more different? How is this anything more advanced than playing the game of chess? Well, for starters, the total number of possible moves in chess is 121 million. All right. So I want you to take a look at this for a moment. 121 million moves in chess. Now that might seem like a lot, but the truth is computers today are so powerful that they just explore the entire solution space. They just explore all possible moves and they've got basically got a cheat sheet on hand to play this against you. So this isn't exactly as challenging as it might seem. But Go, on the other hand, do you want to take a guess as to how many possible moves this can have? It's 10 to the power 360. Yeah. To give you a better understanding of what that looks like, this is what 121 million looks like. And this is what 10 to the power 360 looks like. Yeah, that's a lot of zeros. Turns out this happens to be more possible moves than the total number of atoms in the universe. Yeah, that's right. More moves than the total number of atoms in the universe. That's a lot of moves. And obviously, that's impossible for any computer this day until now to explore the solution space. So, if you want to solve a problem like Go, you would actually have to develop some form of more advanced artificial intelligence to actually play this. And it's much more complicated than just exploring the solution space. So, obviously, the developers put this to the test, and Google DeepMind developed a program called as AlphaGo. And AlphaGo, so what was different about AlphaGo is that AlphaGo was never taught how to play the game. AlphaGo was just given the rules of the game and it was asked to learn on its own. They left it running for over thousands and thousands of simulations, and eventually the game learned to play Go on its own. They put this to the test. So they put AlphaGo against Lee Sedol, which was the 18-time world champion. And you want to know the results? AlphaGo won 5-0. That's right, against the 18-time champion, 5-0. That is significant in the game of Go. And so this was so advanced that the truth is this was an artificial general intelligence. So what happened was it was making moves that the community had never seen before. In fact, some of the strategies that it was using was so different that no one had ever seen before. At some point, the developers couldn't understand what exactly it was doing. Today, these strategies that AlphaGo made that day, are being used to train the new generation of Go players. That is how significant it was. Now, I said it is an artificial general intelligence. What does that mean? So the thing is, this AlphaGo was not just the created to play the game of Go. It was a general intelligence. So what happened was the same algorithm, the same learning approach that it used to play the game of Go, it could also apply the same approach to solve other problems. So what happened? What they did was they took the same general intelligence and tasked it with the problem of reducing the power consumption on Google's data centers. And the result, AlphaGo was able to reduce the power consumption by 40%. That is significant. It was something no human engineer was able to achieve. So I want to take another example here. Do you recognize this car? This is one of the most recognizable cars on the market right now, the Tesla, right? So, what is the feature that stands out the most about it? Self-driving ability, one might argue, right? Yeah. So the thing about the self-driving ability is it's not just hard-coded as to drive on the route and don't bump into a car or something like that. It is much more complicated. It's much more complex. So along with the self-driving capability, there is automatic collision detection. All right. So there is some form of machine learning intelligence put into this to foresee the possibility of a collision and avoid it. So take a look at this example. Yeah. So do you see that? They did not directly collide into it, but the sensors, along with the machine learning on board, was able to identify, was able to foresee the potential threat, and was able to act accordingly. So this is called automatic braking on the Tesla, and there is complex intelligence that goes into it. I will give you another more intense example. So this happened earlier in 2020 in the United States. So during Storm Dennis. So what I want you to do here is I want you to put yourself in the shoes of the driver, right? So what happened was this was in the middle of the night, in the middle of a hurricane. So this family was driving in the middle of a forest and with very low visibility, right? So what happened was all of a sudden the Tesla just stopped, right? In a moment, the driver thought it was a malfunction, but a split second later, a 400-year-old oak tree collapses on the hood. Take a moment to process what happened. The the Tesla foresaw the imminent threat despite low visibility in the middle of the woods during a hurricane at night, and it kicked in the automatic braking, right? So this is if you were in that position to steer, to foresee this threat and move out of it, do you think it would have even been possible by a human? it there is no visibility in front of you. In fact, just imagine your peripheral vision. How would you have time to react and respond to this and move out in time? A split second later and this would have fallen on the roof of the car. So, and what happened was the Tesla, in fact, was able to save the lives of all five passengers on board. So this is significant. It is a breakthrough in terms of life-saving features, right? I want to talk about another example. So this was developed by Google in 2018. So they tasked an AI with diagnosing diabetic retinopathy, which happens to be a degenerative eye disease. And the goal was to diagnose this disease with just the images of the retina. And what happened was it was able to perform this task significantly well, but it was also able to predict the risk of cardiovascular disease 4 to 8 years in advance before the patient actually got it using the same images of the retina. And not only that, using just images of the retina, it was also able to predict other factors such as the age of the patient, the gender of the patient, the smoking habits, the chance of diabetes, and all of these other things accurately using just scan images of the retina. So that is mind blowing. Using They also used tasked another AI with over billions of data points about patients that were admitted into hospitals. And what the AI was able to do was it was able to predict the risk, the chance of being readmitted into the hospital 24 to 48 hours in advance. For 24 to 48 hours in advance. Yeah. So all of these concepts, these seem like very interesting examples. All of these things were realized using a concept called as deep learning. Now, this is another term that we are throwing into the mix. You have deep learning. What is deep learning? You also have something called as machine learning, and you have something called as artificial intelligence. So, what are these concepts? Some people tend to use these concepts interchangeably, but what are they really? Are they interchangeable? No. So the thing is, deep learning comes under is a subset of machine learning. But what is machine learning? Well, machine learning comes under the umbrella of artificial intelligence. This is what that might look like. So the thing is, artificial intelligence is merely a concept. It is a concept that deals with machines being able to think on their own. Machine learning, on the other hand, is algorithms. They're algorithms that learn and improve as and when they get more data available. But deep learning, on the other hand, is multi level neural networks and they deal with large amounts of data, right? So let's talk more about neural networks. What are neural networks? When you look at the term neural networks, what is the first thing that comes to your mind? The word neural networks. Think about this. The first thing that might come to your mind is neurons, right? And what, to our knowledge, is the most complex arrangement of neurons? The human brain, right? Yes, correct. The human brain. And that is exactly what neural networks are modeled after. Well, at least they hope to be modeled after, because the brain in itself is in fact incredibly complex, and we are nowhere near to understanding the complexity of the human brain. But we attempt to model the neural networks after the human brain. And this is what it might look like. So this is a very primitive, a very watered down representation of what a neural network might look like. So you've got a bunch of nodes and they're all connected together in a wired mess of neurons, right? So you've got an input layer, you've got stuff that, so you've got some processing that happens in between, and then you get the result. This might look like something that's very new or very complex, but the truth is neural networks have been around for over 50 years right now. But they've only been realized today in the recent few years because of the immense computing power that we've been able to achieve so far, right? So you might ask, oh, what can neural networks do? How is this different? Take a look at this example. So this was created by NVIDIA using the GAN, adversarial network. And what this AI does is you can give it some basic drawings, like something that you might draw in paint, and it converts those drawings into lifelike pictures. So let's say I would draw something very simple, something like this, something that a child would draw in paint. So this is the input that I would give to the AI. And do you want to see the output? This is the output that you get. Exactly. It converts it into such realistic, hyper realistic, lifelike images. Let's look at another one. Let's say this is what I would draw. This is the input that I would give to the AI. And this is the output that I would get. Exactly. Exactly. Take a moment to admire how hyper realistic that looks. Yeah. So I want to give you an activity right now. So are you ready? I'm going to show you a few images on the slide right now, and you have 1 minute to guess what is in common. All right? You have to guess, you have to figure out what do all of these people have in common. Your time starts now. You can reply in the chat box. Yeah. Facial expression, eyes, teeth, nope, eyes, smile, nope. It's a trick question. Think about it. You have 1 minute to figure out what do these people have in common. Nope. Laughing? No. Anyone else? You have about 20 seconds left. Generation? Nope. Generation, look, what do you mean by that? Years? Has anyone else figured it out? Okay, I'll tell you what it is. What's in common is that none of these people exist. Yeah, none of these people are real. All of these faces were generated using artificial intelligence, and none of them exist. Yeah, they're so accurate that these faces convince they trick you into thinking that these are real people, that you've seen them somewhere, but in fact they don't exist at all. Exactly. Yeah, it is very difficult to believe. Yeah, so that's what AI can do. So I want to show you another example. So this University of Andrews, UK, what they did was they were tasked with identifying the material, the texture, and the consistency of objects without any cameras. There was no vision involved. It was just touch. It was basically radar sensors and other pressure sensors, and they were supposed to identify what an object was without looking at it. This is with. So just look at that. There are no cameras on board, and they're able to predict accurately what metal you're placing on it, what liquid you're putting in the cup as well. That accuracy, they're able to. Just, I want you to take a look at this video again. They're accurately able to predict air, plastic, water, milk inside a container. No cameras, just sensors, touch sensors. So this is the closest thing that we have created that can simulate human touch in machines. Yeah, so I want to give you another example. So this artificial intelligence developed by MIT, what happens is you give it a still image, a photo of any moment in time, and what it gives you, what happens is it predicts 2 seconds into the future. Yes, 2 seconds into the future of a photo, video and gives it to you. Look at this. That is the input and that is the output. It creates a video of 2 seconds into the future. That is absolutely mind blowing. And in fact, how they achieved this itself was a feat on its own. So what happened was they did not use just a single AI, they used two different AIs. They used a generator and a detector. So basically, they had two AIs compete against each other. One of the AIs just generated the two videos of the future, and the other one detected whether or not the videos were real or fake. Over time, what happened is the generator got so advanced that it was able to outsmart the detector. And those are the videos that you are seeing on the screen right now. So that is a very interesting way of developing neural networks. So I want to give you another example. So this was by Boston Dynamics. So I assume most of you have heard of Boston Dynamics. They're in the news a lot recently. Boston Dynamics deals with developing robots, humanoid robots, biped robots, all of these things. And what happens is for the movements of these robots, you cannot just hard code something like just use two legs and like one step forward, one step back, or something like that. These robots are designed to work in industrial environments. So you need very accurate, you need very precise movements, you need the ability to recover from real world um, obstacles because you don't know what's going to be in the real world, what these robots are going to face. So they applied machine learning to develop human like movements. Take a look at this. Look at how it uses the arms to counterbalance. Look at that one more time. Yeah, look at how it moves the hips and the arms as well together while maintaining counterbalancing. So this is something that could not be hard coded into the system. This was something that it learned on its own through machine learning. Also, on the topic of this, when you're talking about putting these machines in the real world, they're going to be real world obstacles. So these machines are also able to recover and be persistent to achieving the goal. Take a look at this. Look at how it does that. This, it hasn't been hard coded to do something like this. You can't hard code this. All of this is developed using machine learning. This is the scariest part for some people. Yeah, it just gets up on its own. So all of this happens using machine learning. In addition to that, take, I hope all of you are familiar with OpenAI. So Elon Musk's startup OpenAI is also hitting pretty big news recently regarding the GPT technology, right? I hope some of you might have heard of it, right? So OpenAI, what they did was they were tasked with having a machine learning a robotic hand learn how to handle a cube. So the task given to the hand was basically to face the cube a particular side, something like this. If you ask it to face the side n, it turns it to that side. But the thing was, they never taught the robot hand how to move a cube. They never taught it how to use the fingers, how to handle objects. It was supposed to learn this movement of holding objects and rotating them on its own, right? And how do you do this? So, why is this a more complex problem? In the case of Go that you saw previously, they just let it run for over 1,000 simulations and it just happened, right? Because you ran it, it's just software, you run it over and over again. But in this case, you have the problem of being limited by the physics of reality, right? You are limited by time, more specifically. You cannot have you cannot have the robot hand move it over thousands and thousands of times, right? Because that would be very time consuming. So what did OpenAI do? So they used an approach called as domain randomization, where they would vary certain parameters and run the simulations in parallel. So for example, they would vary the size of the cube, they would vary the mass of the cube, they would vary the gravity of the space sometimes. So they would vary all these parameters in parallel while while the hand was running the simulations. So this using this domain randomization, the robotic hand ended up having over 100 years experience handling the cube. And so by the end of this, it was able to do the task flawlessly. But what happened was it was able to do things that the researchers never predicted or never even coded expected it to do. It was able to handle other objects, not just cubes. And it also developed human like behavior, such as finger pivoting and sliding. Just look at that. These are some things that we humans really, and it was in behavior without ever being taught to do something like this, without ever being expected to do something like this. That is insane. So all of these things come under a category called as passive AI, because if you think about it, the AIs that we have so far are no different than the tools that we had back in the day. They are passive, right? Since the Stone Age, the chisel only struck where you strike it, right? But we are moving from passive AI to something called generative AI. Generative AI is something that isn't limited by doing what you tell it to do or how you tell it to do in the same way, in the exact way that you expect it to do. So these tools learn on their own. These tools have the freedom to design and create on their own. There is creativity in these tools. So there are research teams working on generative AI. So there was this generative AI that was tasked with redesigning a swing arm, which happens to be the rear suspension of a bike. All right. And what this generative AI did was, so what happened was the AI was not given any idea as to how it should look. It had no idea what a swing arm is. It was just given the constraints saying, these are the points it has to attach to, and this is the load in between. This is how much pressure it's going to be facing. And things like it has to be durable to heat, it has to be effective, easy to manufacture, all of these things. It has to be the metals that you use and all these things. So it was just given this, and what happened was the AI iterated through the entire solution space over millions of possible combinations with minor iterations, and it simulated the real world scenarios. It simulated every design in real world scenarios and tested the durability and other things of this. So this is something that would be impossible if you had human designers work on this. Just look at how complex and intricate these designs are. So every angle, every bend in this has purpose, either for durability, either for reducing the cost of manufacturing, or some other purpose. So all of this is is mind blowing as to what the AI can achieve, and it was realized using 3D printing. So, in another example, the AI was also tasked with redesigning the chassis of a drone. And again, it was just given that it had four propellers and a body in the center, and it iterated through the entire solution space and simulated the aerodynamics of every single design. Yes, millions of possible designs. So this is something that was possible using generative AI. But generative AI has its limitations. If you've caught it over the past few examples, generative AI has to start from scratch. It has to create every single possible design and iterate through a million different designs. It has no understanding of whether a design would work or not without running the simulation, right? So that is where something called intuitive AI comes in. Intuitive AI basically deals with intuition. And what is intuition? Intuition is something that we humans just know naturally without having to ever experience it, right? People could just look at designs and say, this doesn't make sense, or this wouldn't work, right? So AIs don't have the ability to just know without doing it, without actually testing it. So this is where intuition comes in. I'll give you an example. Let me ask you a question. Would you dance on the edge of this cliff? Yes? No? Even the first reaction that you look at this would be, of course not. I would not dance. Nobody would, yeah, no, I can see a lot of no's in the chat. Nobody would just dance on this cliff. And why do you say that? Just think about how you got to that conclusion. Did you stop and did you think saying, can I not, would it work? No, did you simulate it? Did you test it? No, you just arrive at that conclusion naturally, instantly. So that is what intuition is. And this is something that we are trying to teach to artificial intelligence. And one of the approaches that researchers have theorized is the nervous system. So it is theorized that it is the nervous system, not just in the brain, but the entire body's nervous system that helps in arriving at intuitive decisions, right? So they put this to the test. So they decided to fit a race car with its own nervous system. So they added sensors and detectors on every point, every stress point, and every mm, bend and curve of the race car chassis, and they allowed it to they basically tested it with this nervous system, where they collected over 4 billion data points as to how it moved, how the wear and tear, the heating, the damage, all of these things. So they simulated this nervous system collection with over 4 billion data points. And they took these data points and gave it to an intuitive AI to redesign what a race car chassis should look like. And this is what it came up with. Just look at the complexity of that design. So the first thought that you might get when you look at this design is, what is this? What is this design? How did you get here? But the truth is, it analyzed 4 billion data points about stress, durability, wear and tear, life of the parts, cost of manufacturing, all of these things. And using every single data point, it has simulated the best possible design that a chassis can have. So just imagine if you asked a designer or even a group of human designers to create this design from scratch without having seen this, it would be impossible, because every angle, every bend, every curve has a purpose for it in this design. So this is so this uh, so this is some of the beautiful things that intuitive AI can create. Let's take a moment to talk about the future of AI. So where do we stand now? If these are the things that AI can create, this is something that we would obviously want, right? So where are we going with this? This is what we've got so far, but well, what's in store for the future? When you talk about the future of AI, you end up having a deeper discussion about the future of humanity itself. Let me ask you a question. Um, I want you to take a moment to think about how movies would portray the future of AI in their own sci-fi manner, right? The first thing that might come to your mind is something like this, right? So this is how most movies would portray the future of artificial intelligence and computers, saying that some super intelligent AI would just take over the world and destroy humanity, right? But I want you to think about this. Is this a likely future? Is this a reality that will? How far do you think? How far away do you think a reality like this is, if it even is possible? Okay, someone says no. This sort of future is not possible at all. Anyone else? What do you think? Is a reality like this possible? Think about this, right? Um, Ever since the dawn of humanity, we have continued to create tools, right? Ever since the Stone Age, to the invention of the wheel, to the industrial age, to where we are now, we have continued to create tools, and we have continued to improve our machines, right? And if you think about it, in the long run, we will continue to improve our machines. For as long as time goes on, okay, someone says if there is no control over it, it may be possible. Well, yes, you might be right. So, for as long as time goes on, we will continue to improve our machines, right? For as long as humanity exists, we will continue to improve our tools. We will continue to make progress in science, in technology, in the advancements that we make, right? So I want you to ask yourself this question: will we ever stop? Will we ever stop making progress? Will our computers stop getting faster? Will our phones stop getting smarter? Will we ever stop? No. That's the hard reality of it. For as long as humanity exists, we will not stop innovating, right? So researchers a few decades ago theorized maybe if there was a global pandemic, we might stop innovating. But the truth is, we are in a global pandemic right now, and we have not stopped innovating at all. We will continue to make progress year after year after year. Our machines will keep getting better and better. Our machines will get smarter and smarter. So that still doesn't mean that we will get a reality like this where all our machines will suddenly go against us. No, that's not the reality. But you have to understand that if we continue making machines that are smarter than us and faster than us, we will eventually make machines that can improve themselves, right? When we create machines that can improve themselves and are much smarter and faster than us, then you get something called an intelligence explosion, right? So, and we will continue to do this. So the question is not if we will get machines that are smarter and faster than us and much more competitive than us. The question is when we will get this. When will we reach an intelligence explosion? Because the truth is, we will continue to do this. We have problems we want to solve. We want to do this. We want to cure climate change. We want to end world hunger. We want to end poverty. We want to cure diseases like cancer and other things. We will continue to do this. We want to create machines that are smarter than us, faster than us, better than us in every possible way. So we will reach an intelligence explosion. So I want you to think about the spectrum of intelligence like this. So let's say this is where you are. So this is how intelligent you and me are on the spectrum of intelligence. And let's take someone who that we consider is one of the smartest people of our time. So I will take Stephen Hawking, for example, right? So let's say that's how intelligent he was. And let's just take something else on the other end of the spectrum. Let's say a chicken. Sorry, a chicken. Yeah, uh, not try. Yeah, a chicken. So this is a spectrum that we are looking at, but it is more than likely that this spectrum extends far beyond what humans have ever been able to explore. And what I mean when I say far beyond, I mean far beyond what humans have seen. So if we end up creating machines that are much smarter than us, it is more than likely that they will explore this entire spectrum in ways that we could have never imagined. And this is true by the factor of speed alone, because electrical circuits are over 1 million times faster than biochemical circuits. That's 1 million to 1. You do the math on that, and let's say you develop even a basic form of primitive super intelligence, and let's say you leave it running for 1 week. In 1 week of time, that AI would have made 20,000 years of progress. That's it, 20,000 years of human progress in 1 week. How could you even understand, much less comprehend, an AI making this sort of progress? Now, people say machines, people say this is nothing to worry about. This is something that is maybe 50 years into the future or something like that. It's nothing to worry about. But the truth is 50 years is honestly not that much time. This is what 50 years looks like in months. This is how long a smartphone has existed. This is how long The Simpsons has been on television. If if an alien species came down to Earth saying, "We will arrive on your planet in 50 years," we would not be this calm about it. Right? It's 50 years really isn't that much time. And the bigger problem here is we have no idea how long it will take us to create the conditions to do that safely. We will end up creating super intelligent AI, and read that again. We have no idea how long it will take us to create the conditions to do that safely. So if you aren't concerned about the future of AI right at this point, you probably should be, right? So what is the solution to this problem? Unfortunately, there isn't one direct solution as to creating AI that will perfectly be in line with our goals. But there are some holistic guidelines that we have to follow, right? We cannot go all in when we create our own super intelligence, or when we're on the verge of creating intelligence. This is exactly the reason why we have guidelines or ethics to be followed, right? So we must proceed cautiously while creating AI or any form of primitive or super intelligent AI. We must abide by ethics while creating intelligent machines. We must open source as much as possible to prevent complex machines, powerful machines like this falling into the hands of the Googles and the Amazons, creating other problems like wealth disparity and other things. We must build responsibly, and we must do so in ways that align with our interests. Because when we do, we can make beautiful things happen, right? So this is something that we are moving forward with. We will create beautiful, powerful machines, machines that can solve world problems, machines that can cure diseases, machines that can do all of these beautiful things in ways that align with our interests. Then the truth is, machine learning and artificial intelligence is the future of technology. And all of us, if you've been paying attention, would want to be a part of this future, would want to be a part of this super intelligent future. Yeah. And how you would do this would be to develop, to learn how to develop super intelligent machines, or at this point just primitive intelligent machines, right? So how do we do this? How do we develop super intelligent, sorry, primitive intelligent machines, intelligent machines, let's just say at this point. We're not there yet, right? So how do you develop intelligent machines? At this point, to develop machine learning models, you've got a lot of tools on hand. So you've got something called as TensorFlow, right? Which is by Google and it's open source. You've got something called as Jupyter Notebook that lets you develop machine learning models in Python. And you've got something called as Google Cloud Platform. So the Google Cloud Platform happens to be the most advanced one on the list here, right? So how do you get started with these? So these, when you see these logos on screen, it's more than likely that you haven't seen these logos before, right? These are very new tools that you might be seeing. So the question is, how do you work with this? How do you get started? How do I develop for machine learning? How do I develop for artificial intelligence? Right? You, because these are things that might not be taught in the curriculum just yet, right? So how do I get started? All you need to get started is a little push, right? So for that, you can check out our website, nextup.co.in/ml, and it will be on the chat box as well. So we offer machine learning resources and other things. So just to help you get started with developing for machine learning models, to help you get an understanding of how to start developing for machine learning, right? So, and if you require any more assistance, you can get in touch with us on the website as well, right? So thank you, everyone. So this has been the world of machine learning. Hope you got a great idea, a holistic idea of what we are developing right now and where we currently stand in the field of machine learning, and what is the future of machine learning going forward. Yeah. Thank you, everyone. Back to AMC in case there's anything.
Hello, can you hear me?
Yeah, you're audible, ma'am.
Yeah, Shayan. It was a very good informative session. Even I didn't know much about this AI. Most the last few slides were even new to me also. Very good because I think the students are your friends have been benefited by the session. Very good. I request all of you to take up the courses either in Nextup or in AMCEC if we conduct or anywhere, but keep abreast of the technology. As Shayan rightly said, it is not a part of curriculum yet, and it's like it takes time for the universities to include it in curriculum. So it's our responsibility, both as a teacher and the students, to take it up, and we are at par with the industry standards. So I request you all to take up all such courses, whichever trendy of your interest, not only ML, anything which triggers your interest, so that you build up your future in that, your future and also career in that particular field. Okay, thank you, Shayan, once again. And I thank all the participants for your dynamic, interactive participation, not just a passive, it was an active participation from all of us, all of you rather. And I also thank Shri Vidya ma'am for coordinating it, and Mushtaq sir, who is the wearing steering wheel. He has that powers of driving all these webinars and online events of AMCEC. Thank you, Mushtaq sir, and thank you all once again. Have a good day. Thank you.
Thank you.